Yay. So Quiz10. It says use upper sums in 4 rectangles to find the approximation of the area of the region between the graph of the function 9 minus x squared and the x-axis. Okay, so there's a lot of work. Our function's 9 minus x squared. What does that look like? Upside down parabola, but shifted up 9, right? So that, yeah, that makes my x-intercept negative 3 and 3. So 1, 2, 3, 4,
Talking about,
5, 6,
yeah.
7, 8, 9. Something like that. So this is my function. Now I want to use 4 rectangles and upper sums to approximate the area between this graph and the x-axis between -1 and 3. So I'm given this interval, -1 to 3. So the area that I want to approximate is from here to here, so it's this green area. Now, I have to use 4 rectangles and upper sums. The tricky part about this, hopefully, is not the width of the rectangles. What's the width of the rectangles? 1, right? Because you take the entire interval, which is from -1 to 3, so that distance is 3 minus -1, over the number of rectangles, which is 4. So each rectangle has to have width 1. Now, the tricky part is getting the upper sums. Okay? Starting at -1, to get an upper sum, you don't want to go up to the graph on the left, because if you go up to the graph on the left here, you're going to get a rectangle that's underneath the graph. So instead of going up on the left, you have to go up on the right. So your rectangle goes up to 0 like this, and then comes over like this. This is your first rectangle. Otherwise, it won't be an upper sum. So you have to come up on the right to make this rectangle outside of the area, and therefore an upper sum. But then on the next interval, from 0 to 1, on this next width, you again have to stay above the graph, so you can't come up on the right again, because if you come up on the right, you'll go under the graph. So you have to again come up on the left, and then go over like this. So your first 2 rectangles should both have width, I'm sorry, not width, height 9. Because your first 2 rectangles are both going to have to come up to the vertex. Then after that, it's a little more usual. This rectangle is going to come up to the graph on the left to make it an upper sum, and this rectangle is going to come up to the graph on the left again.
You see?
So you just have to find the area of these 4. Get your approximation. How am I going to get the height here? I mean, you can eyeball it, I hope, right? The height of these rectangles should be 9, but how do you technically get it?
You plug in that point into your
Right, you plug this point where your rectangle actually touches the graph, or the corner of your rectangle touches the graph, you plug that x value into your function. So technically I would do my width, which is 1, times f of 0. Right, times 0, I plug it in here. But I have to do that for both of these rectangles because they both touch the graph at 0. So plus 1 times f of 0 again. Plus, then my second, or my third rectangle here touches the graph at 1. And then my fourth rectangle touches the graph at 2. So my area will be 1 times f of 0, so 1 times 9, plus 1 times 9 again, plus 1 times 8 when you plug in 1, plus 2 times
1 times 2.
I'm slightly dyslexic. There we go. So this should be 1 times f of 2, so it'll end up being 1 times 5. So 9 plus 9, 18, 23, 31. Square it. So the problem is that the problem is basically that, this guy over here is increasing, but this guy over here is decreasing. Right? And when it changes from increasing to decreasing, you have to change where you draw your rectangle to get upper sums. Other questions? Does this make sense now that I drew the picture?
Mm-hmm.
Number 3.
Oops. Find the indefinite integral. Oh. Number 3 on the quiz wants the indefinite integral of the 13th root of x to the 8th.
Maybe it's 4.
Oh, you don't want to do this one? I wrote it, so my OCD is like making me do it now. So, but I will keep track that this wasn't what you wanted. How would you do this though? How do you integrate a root? You gotta change it to a power. Right? Once you change it to a power, then you can use your power rule. So what power is this? The 13th root, so the 13th is in the denominator.
8
8
over
in the
13.
So then you add 1 to the power. If you add 1 to 8 over 13, it will be what? 21 over 13?
Yeah.
Then you divide by that same thing, and you add C. Probably this gets flipped up. So when you divide by a fraction, you flip it up. So that would be my guess. Yeah, that's right. Oh, I see what happened. I did the one from the last quiz for you. Maybe you did want number 3, but I was looking at the wrong quiz. Cool, so that's a good review. I totally know what's going on. So 3 is the one with the sums. Is that what you wanted?
Yeah.
What do we have in here? So once the limit as n goes to infinity of the sum I equals 1 to n, 10I over n times 8 over n. So when you're evaluating these sums, usually you want to try and make them look like the formulas that you know, or that you can look up. Right? So by the formulas, I mean things like the summation of 1 from I equals 1 to n is equal to n. The summation of I from I equals 1 to n is equal to n times n plus 2 over, or n plus 1 over 2. So you want to try to do algebra on this sum until it looks like one of these.
Yeah.
So what can I do first here?
4 to 10.
Pull out anything that doesn't have an I, right? Any constant multiple can be pulled out front.
80.
So the 10 and the 8 are constants. They're going to come out as an 80. And the n times n, that doesn't have an I in it. So it's going to come out as an n squared. So this, and this don't have i's. So they can come out as constant multiples. That guy has to stay in.
Now you have that second formula.
Yeah, so now I can apply my second formula right here to this summation of I, leaving you the limit as n goes to infinity of 80 over n squared times, this guy is n times n plus 1 over 2.
Circle the 8, circle the 2.
Yeah, so 80, let's see, the limit as n goes to infinity, this guy's n squared and this guy's n squared. So altogether, these guys go to 1, because you have n squared on bottom and n squared on top, which means that 80 and the 2 are left over, leaving you with 40. So as long as the degrees are the same, that you just take the ratio of the coefficients for the limit, at least as n goes to 1.
You say we did or didn't need to memorize the formulas.
I'll give you these if you need to use them on a test.